Hello guys and welcome back. On today's video I'd like us to talk about the binomial theorem. So the binomial theorem tells us that if you're trying to expand x plus y to the power k, that is the same as the summation from n equals to 0 to k combination kn x to the n y to the k minus n. Okay, so otherwise there's the same formula that works the very same way, where this part of x to the n y k y to the power k minus n is the same. They will just write y to the n, then x to the k minus n. These are just two same formula. They work the same way. So for the purpose of this video, I'll just use this one. Okay, so I'll disregard this one. Yeah. So now let me explain some part in this equation. What is this? Okay, so that is the combination of k and n. So combination of k and n is basically the same as k factorial divided by n factorial into k minus n factorial. So that is the formula for the combination. So that is how you expand this combination. Okay, so it's k factorial over n factorial into k minus n factorial. So now let's look at a simple example. So it's x plus y to the power 2. So this is much simple example that you can get. I mean, you can even expand this without using the binomial theorem. However, I would like us to do that using the theorem. Otherwise, the thing that you have to do is to chase this x plus y to the power k. So this positive sign there is very important. So you have to always make sure that you are having a positive sign. So let's look at the problem that we are given. Do we have a positive sign? Yes, there is a positive sign. Then we have a power. Then it implies we can start applying the binomial theorem right away, where k in this case, our k is 2. The power is 2. Then the power represents k. That means k is equals to 2. Then we are starting from n equals to 0 to 2, where k, now where we see k, we plug 2, combination n, x to the power n, y to the power k is 2 minus n, just like that. Okay, so now let's expand this series. When n is 0, we are going to get 2 0 into x to the power 0, y to the power 2 minus 0 is just y squared. Then we add that to 2 combination 1, x to the power 1, then y to the power 1. 2 minus 1 is 1. Okay, then plus combination of 2 and 2, x to the power 2 and y to the power 0. Okay, then we can simplify that. So this is what we got. We can simplify it. So if we simplify, we are going to apply the combination equation that I wrote for you guys here. This is the same. K is 2 now, and our n is 0. So we are going to have 2 factorial divided by 0 factorial into 2 minus 0 factorial, just like that. Then x to the power 0, that is 1. So we are left with y squared here. Then plus, then we're going to have 2 factorial divided by 1 factorial into 2 minus 1 factorial, just like that. Then xy. Then plus 2 factorial divided by 2 factorial into 2 minus 2 factorial. Okay, then x squared, y to the power 0 is 1. Okay, so from here, this one and that one will cancel. Then 2 minus 2, that will be 0 factorial. So here we're going to be left with x squared. So we see that there we're going to be left with x squared from here. Okay, then here we can say this is 2 minus 1 is the same as 1. So 1 factorial times 1 factorial is the same as 1. Then 2 factorial is 2 by 1. So we're actually having 2xy. Okay. Then here, let's see, what do we have? 0 factorial is 1. Then 2 minus 0, that's 2 factorial. 2 factorial and 2 factorial, they cancel each other. So we basically have y squared. So this simplifies to y squared plus 2y plus x squared, just like that. Okay. So let's look at another example. This one was a pretty high example that you can easily go around. Okay. So now let's suppose you have another example like this. This is the example where you are asked to find the coefficient of x to the third in the expansion of 1 all over root of x minus x squared all to the power negative 4. So copy down this question so that we can start solving it together. So what is the first thing that we want to do? Remember, I'll start writing down the binomial theorem. It says x plus y to the power k is the same as summation from n equals to 0 to k into k combination n, then x to the n, y to the power k minus n, just like that. Okay, so in order for us to apply this binomial theorem, like I said on the first example, we have to chase this side. Okay, so we are actually going to chase this side. We want to have a format that says something plus something to the power k. So we're basically going to chase such that we have a plus there. Okay, so let's work out this problem and see. We are given 1, it's 1 all over root of x minus x squared to the power minus 4. Okay, so if that is the case, then the first thing that we can do is to rewrite this. So this is the same as saying the square root is the same as x minus x squared to the power half. Okay, then everything to the power minus 4. Then I can say this thing is the same as if I'm having this, the reciprocal of it, then it's going to be x minus x squared to the power minus half, like that. Okay, so if I have x minus x squared to the power minus half is the same as 1 all over x minus x squared all to the power half, right? So everything must be to the power negative 4, just like that. So I can multiply these two powers. So if I multiply those two powers, what do I get? When I multiply those two powers, I get x minus x squared. The negatives are gonna cancel, then 4 divided by 2 is basically x minus x squared to the power 2. So sometimes they are not gonna give you something that is in an easy way out. You'll first have to manipulate it and put it in a format that is much more simpler to work with. So now we have this. Are we able to apply the binomial theorem yet? No, we cannot yet apply it because of here we have a negative sign. Otherwise, what are we chasing is a positive sign in between the two terms. So here, for us to get a positive sign, what can we do? That is much simple. We can just say this can be rewritten as x plus, then open bracket, x minus x squared, okay, minus x squared all to the power 2, just like that. So now when it is in this format, we have two terms, is this one and that one in the bracket there. Okay, then our k is 2. So now we can apply the binomial theorem. So what we got there is x plus into minus x squared to the power 2. Then if we apply the binomial theorem, our k is 2. So the summation from n equals to 0 is that's where k is 2 up to, is that's where n is 0 up to 2, I mean. Then k is 2, then we plug 2 combination n. Okay, so where there is k, now I plug 2 in that formula. Where there is k, I plug 2. Okay, so I'm pretty sure you guys now should be memorizing the formula and being able to apply it. Then x to the power n. So here is this x. This x, I'm plugging it here. It's the same thing, x to the power n. Okay, then multiplied by, now where there is y there, where there is y, I'm not gonna plug y. I'm gonna plug minus x squared. Okay, so I'm gonna have minus x squared to the power 2 minus n, just like that. So I will repeat that again. When you are expanding this problem, where on the first one, the first term is x, the second term is minus x squared, the one in the bracket there. Okay, so according to this formula, the first term was x, we plug it there. The second term was y, we plugged it there. So now here, instead of y, we are not having y, we are having x that we plug there. Then we are having minus x squared that we have to plug in there. Okay, so that is why I don't have a y there. I plug minus x squared. If you still don't understand what I meant, feel free to rewind the video. Okay, so now I can manipulate the series that I'm having here. So it's n equals to 0 up to 2, then 2 to the n, okay, then x to the n. Then what I can do from here is to say, okay, I want to put out this negative, okay? So if I'm putting out this negative, that is the same as having negative 1 to the power 2 minus n, okay? Then what is remaining is x to the power 2, but that 2 now I'm going to multiply it with that. Okay, let me not rush it for the sake of those who are not following. So I'm just going to plug it like that. Okay, so I have not changed anything. This is the same as this whole thing here. Okay, I just separated there. So now what are we going to get? We're going to get summation from n equals to 0 up to 2 into 2 combination with n. Then I'm going to put this here. Then it's minus 1 to the power 2 minus n, then x to the power n, then x to the power 2 by 2, that is 4 minus 2n. Okay, so these two, they have the same basis x. When bases are the same by law of exponents, what do? We add the exponents. So that is going to give us summation from n is 0 up to 2, combination of 2n, then minus 1 to the power 2 minus n, then that is going to be x minus x to the power, x to the power 4 minus n. Okay, n minus 2, and that is going to give us minus n. Now I can start expanding the thing. Let's plug n is 0. If we plug n as 0, we get 2 combination 0 to the power minus 1 to the power 2. If n is 0, then it's just minus 1 to the power 2, which will be positive. Notice that this term here is just there to give us a positive, negative, positive, negative. Our series is basically oscillating. It's alternating between negative and positive. Okay, so yeah, now this part is gonna be positive. Then we plug 0 there, we get x to the power 4, right? Then combination of 2 and 1, right? Then when n is 1, is 2 minus 1. So minus 1 to the power 1, that is going to be minus 1. So that's where now we get a negative there. Negative 2 combination 1. Then x to the power 4 minus 1, that is x to the power 3. Okay. Then the other thing is when now n is 2. Okay. So if n is 2, we have 2 combination 2. 2 combination 2, I plug 2 there. Then if I plug 2 there, it's going to be minus 1 to the power 0. Minus 1 to the power 0, that will give us something that is positive. Then x to the power 4 minus 2, then that is x squared, just like that. So what is left of for us now is to expand the combination. So 2 combination 0, we already know the formula, that is going to be 2 factorial divided by 0 factorial into 2 minus 0 factorial. Okay, into 2 minus 0 factorial, just like that. Then x to the power 4. Then minus 2 factorial into 1 factorial, 2 minus 1 factorial, just like that. Then x to the power 3. Then plus 2 factorial divided by 2 factorial into 2 minus 2 factorial. Then x to the power 2. Okay, so this will simplify to this is basically 2 factorial over 2 factorial. Here we're gonna have x to the power 4. Then this one will just simplify to to just 2. So we have minus 2x to the third. Then this one will simplify to just 1, because this and that will cancel. Then it's just simply 1, then plus x squared. Okay, now let's go back and remember what the question was asking us. So the question wanted us to what? To find the coefficient of x to the third in the expansion of that. So we have expanded that, and the expansion gives us x to the 4 minus 2x to the 3 plus x squared. So what is the coefficient of x to the third? We are here. The coefficient of x to the third is basically minus 2. So therefore, coefficient of x to the third equals negative 2. So that is now the answer to the question. Okay. So the other example, they can say use binomial theorem to find the constant term in x minus 2 over x squared to the power 6. Okay, so they specify that you should use the binomial theorem. So the first thing that you want to do is to expand this and find the constant. So let's do that quickly and see. So we are given x minus 2 all over x squared all to the power 6, just like that. So we see that we cannot yet apply binomial theorem because of this negative sign, but that is not much of a big deal, since we can just say x plus, then we put everything into bracket like that, then all to the power 6, isn't it? So in this case, now we know our k is 6, then we can start applying the thing. So that it will be equal to summation from n equals to 0, where k is 6, okay? Then combination of 6 and n. Then our first term is x, so I can just put it as it is, x to the power n. Then now where there is y, I'm going to plug minus 2 all over x squared to the power k. It says to the power k minus n, so it's 6 minus n, just like that. So now let's simplify further. We can say we have n equals 0 to 6, then 6 combination n, just like that, then x to the power n. So I'm gonna do the same way. I don't want to deal with this negative 2. Okay, so I'm just gonna have negative 2 to the power 6 minus n, isn't it? Then here what I have is x. It's, if I put out negative 2, I'm left with 1 over x squared, and 1 over x squared is the same as x to the power negative 2, then 6 minus n, just like that. So now let's do few more steps. So n starts from 0 to 6, combination of 6 and n, x. Okay, let me put the constants together. So I'm gonna put this one minus 2 into 6 minus n, just like that. So here we get minus 2 by 6, that is minus 12, then plus 2. So that is x to the power minus 12. Okay, then plus minus 2 by minus n, that is 2n. But remember, there is also an x there that has a power of n, so I can just simply say to the power of 3n, just like that. Okay, so here I was going to get to the power of 2n, and I have bases that are the same. I already added in. Okay, but if you feel like I'm losing you, you can do it step by step. It's still fine. However, yeah, this is the right way. So now, what is the question looking for? Once I get here, I can start asking myself, what is the question looking for before I expand? Okay, they said we should use the binomial theorem to find constant term. Okay, we should find constant term in this. So if there is a constant term, notice that this is what is going to give us a constant, isn't it? So that is what is going to give us a constant. So these are constants always. Okay, so I can say Cn is equal to 6 combination of n, then minus 2 to the power 6 minus n, just like that. Okay, for the constants, this is what is going to give us the constants. So then, in order for us to find the constant, what must basically happen? What must basically happen is that we don't want to have a variable. So in order for us to not have this variable, what must be the value of n there? Okay, that is how you should ask yourself, what must be the value of n? Because we want to expand the thing where, but now we don't know what n is supposed to be. So if n here is 4, notice that 3 by 4 is 12. Minus 12 plus 12 will give us x to the power 0, which is going to be 1. And x will go away in that case, isn't it? So we're basically going to say, okay, if we have x to the power minus 12 plus 3n, we want it to go away. We want it to have a power of 0. So it can only go away if it have a power of 0. Okay, so I'm basically writing down what I was explaining in terms of equations. So mathematically, you know that if bases are the same, we can drop their exponents. So minus 12 plus 3n, it should be equal to 0. So solving for n, we get that n is 4. Take 12 that side, divide by 3, we get n is 4. Okay, so yeah, that is how we get n as 4, just like that. So now we can find the constant. So the constant n is 4. So C of 4 must be equal to 6 combination 4 into minus 2 to the power 6 minus 4, that is 2. Okay. So this simplifies to 6 factorial divided by 4 factorial times 6 minus 4, that is 2, then is 2 factorial into 2 to the minus 2 to the power 2, that is 4. Okay, so I can simplify this. If we try to simplify that, what are we going to get? We can write 6 factorial as 6 by 5 by 4 factorial. Okay, then divided by 4 factorial times 2 factorial multiplied by 4. So this 4 factorial and that one are going to cancel out. Okay, then what can we say? We are going to be left with 6 by 5 and by this 4 here, this 4 divided by 2. 2 factorial is the same as 2. So how many times does 2 go into, let me just make it go into 6. It goes 3 times, then we're left with 3 by 5 by 4. So 3 by 5, that is 15. 15 by 4, that is 60. So the constant must be 60. Okay, the constant is 60. So that is how you find the answer of this question. Otherwise, what you can do, once you get here, you can do like we were doing on the previous examples, expand this thing. Once you expand it, then you will find that as you are solving somewhere, you will find the number 60. Okay, so that will be the constant. So thank you very much, guys, for watching, and I hope this video is helpful. Don't forget to like and subscribe. See you again on the next video.